Okay, so in this unit, we're going to be talking about solutions. And I know that we usually think of solutions as like fixing a problem, right? But in chemistry, a solution is a homogeneous mixture of two or more substances. Basically, it's a mixture where you mix some things, but it looks like one thing, okay? It's like where you mix a couple things together, but it still has the consistency of one mixture, okay? So a good example would be like salt water, right? You dissolve salt in water, but it kind of just looks like one solution, one thing. And so that would be what a solution is, okay? All right, now solutions are made out of two things that we need to distinguish. So make sure you guys write this part down. Okay, solutions are made out of solutes and solvents, okay? You guys don't need to write the entire definition down, but just make sure you guys write this part down right here. Solutions are made out of two things. They're made out of things called solute and solvents. Okay, so we'll talk about what those two things are, but just keep that in mind. Solutions are made out of solutes and solvents. So solutes are things that are getting dissolved in your solution. So let's go back to that example of salt water, okay? So if we have salt water as our solution, okay? What's the thing that gets dissolved in salt water? Yeah, salt, right? Super easy. So salt would be your solute. It's the thing that gets dissolved, okay? And then solvents are the things that do the dissolving. So again, salt water, what's the thing doing the dissolving? Yeah, water, right? Super easy. I'm not trying to trick y'all. Okay, so water is the solvent. Okay, and typically in our labs coming up, water is always going to be the solvent because we use water to dissolve things inside of it. Okay, any questions about the definition? Yeah. Yeah, if you want to jot that down somewhere, you can. If the salt water example kind of helps you understand what that is, you could do that. You can write it however you like, but just keep that in mind. I'm not going to be asking you on the test what is a solute or what is a solvent, but you'll have to know these terms as we go forward. Okay. Okay, so solutions are made of solutes and solvents. Solutes get dissolved and solvents do the dissolving. Okay. All right. So far, so good on the definitions. Hopefully not too bad. Okay. Now, the reason why we're talking about solutions is because a lot of times in chemistry, we dissolve our chemicals in water. It just makes it easier to work with. And so that's what we'll be doing in our upcoming labs. Now, when we talk about dissolving things inside of a solution, we're going to be talking about something called concentration. So just make sure you guys write that word down, concentration. Okay, and I know typically we think of concentration as, focusing on something, which hopefully you guys are doing right now. But in chemistry, concentration is basically how much solute is in a solution or in a defined space. Okay, an easy way of thinking about it that we're probably more familiar with is if something is strong or if something is weak. Okay, so we're going to be comparing whether something is strong or weak. So one example that I think is easy to understand is alcohol. I know none of you guys are interested in alcohol at all, right? Okay, but anyway, alcohol, you guys know that some alcoholic drinks have more alcohol than others, right? So for example, like vodka or whiskey, that's considered like a strong alcohol. But then things like beer have less alcohol, right? So that would be considered weak. So strong drinks, you can think of them as higher concentration, and weak drinks, you can think of them as lower concentration. Yeah. You can just write that term concentration, but just know the difference between higher and lower. Okay. Okay, so that's an easy way to think about concentration. Okay, the more concentrated something is, the stronger it is, and the lower it is, the weaker it is. Okay. All right, so we're gonna do a quick comparison. I have some stuff up here just to help us visualize concentration a little bit better. But up here I have 3 containers, but let's start with this one right here. So I'm gonna fill it up with 200 milliliters of water. Okay, I'm gonna do that in these 2 containers, so they both have the same amount of water. Okay. And then in one of the containers, I'm gonna put 1 scoop of salt, And in the second container, I'm going to put 2 scoops of salt. Okay, so not trying to trick y'all, but which one do you think is more concentrated? The one with 1 scoop or the one with 2 scoops? Yeah, obviously the one with 2 scoops. Okay, and the reason why is because it has more salt in it, right? So that's an easy way to think of concentration. There's more dissolved in it. Okay, so here, let's jot this down. We can write that, just write this on your paper. We'll say that solution 2 is more concentrated, and the reason why is because it has more solute. Okay, so that's an easy way to think about concentration. If there is more solute, more stuff dissolved in it, then that means it's going to be stronger, right? That's one of the things that's important when we're thinking about concentration. The more solute you have, the more concentrated it is. Okay. All right. Any questions on that one? Make sense? Pretty self-explanatory, right? Okay, but let's take a look at another example. So we're gonna take out the second one right here. So we're gonna ignore this one. So here I have solution 1. It's the same one that we were working with. 1 scoop of salt in it, 200 milliliters. And then here we have one with 2,000 milliliters of water. Okay. Now in the one with 2,000, I'm gonna put 2 scoops of salt. Okay. So which one contains more salt? 1 or 3? 3. Yeah, 3 has more salt, right? Because it has 2 scoops. Okay, but which one is more concentrated? 1 or 3? 1. Yeah, 1. Why is 1 more concentrated? Yeah, it's a smaller space, right? So that's the other thing that we need to keep in mind. Okay, so we need to keep in mind the volume. Okay, so this one is more concentrated because it has less volume. Okay, so those are the 2 things that you want to keep in mind when you guys are thinking about concentration. Okay, the more solute there is, the more concentrated it is, and the less volume there is, it's going to be a higher concentration. Okay, and so those are the 2 things that you want to keep in mind when you guys are thinking about concentration. Yeah.
So less volume, like generally means.
Yeah, it'll make it more concentrated. The smaller the volume. Okay. All right, and since usually I have people to ask, does anyone want to test it to see if you guys are right or not? You want to drink the salt water?
Yeah.
All right, come up here. Here's some of this nasty salt water.
No.
You're good? Okay, never mind. Change his mind. All right, but you can trust me on that. Solution 1 will be insanely salty. Solution 3 will just be okay. It'll just be a little bit salty. Okay. All right, so that's gonna be it for the definitions. I just wanted to check because there's always one crazy person that wants to drink the salt water. But hopefully, good thing there's no crazy people here. Okay. So let's get into the math part. So these are the problems that you're going to see in your assignment, and we're just going to jump right into a couple of practice problems, and then after that, you'll get started. So what I need you guys to write down is this equation right here, okay? This one right here on the right side. The one on the left side is kind of the explanation, but we're going to be using it so you'll understand what the variables mean. And if you ever need to go back and refresh your memory, this is all posted on Canvas, so you can look it up. But this right here in the pink box, this is the one that you guys have to write down since this is the one that we'll be using the most, okay? So the way that we measure concentration is we measure concentration in terms of something called molarity, which is the name of the lecture, right? And the way that we find molarity is we substitute molarity with capital M, and molarity is equal to moles divided by liters. So if you guys remember, we learned about moles last time. Okay, but basically, if you want to calculate how concentrated something is, you just find the moles inside the solution and you divide it by the liters. Yeah.
So like for number 1, 0.8 divided by 1.
Yes, you spoiled the answer, but yeah, that's how you do it. It's all good. Okay, so if you guys look at it, you could see the top is talking about the amount of solute. Okay. And the thing on the bottom is talking about the volume, the 2 things that we talked about. Okay, moles tells you how much solute there is. The liters tell you the volume. Okay. just make sure you guys have that written down. You'll basically have to memorize it for your test, but shouldn't be a big deal. We'll be using it literally all unit. Okay. And one last thing I want you guys to write down is this right here. 1 liter is 1,000 milliliters. You're gonna have to know this because if you guys look at it, liters are like this big and milliliters work with about this much. And so when we do our lab and stuff, we're not going to be working with liters of water, right? That's just a waste of water. So usually we work with smaller amounts, but we need to turn that into liters. So that's why you're going to have to know this difference. If you guys want a little cheat sheet on how to use this, when you're going from liters to milliliters, what you want to do is multiply by 1,000. But if you're going the other way, if you're turning milliliters into liters, you're going to divide by 1,000. Okay. So if this makes more sense to you, you guys can jot that part down. If this makes more sense to you, you can jot that down. Either way, it's the same thing, but you will have to convert between liters and milliliters. And we'll have a couple examples of those in a little bit. But just make sure you have these two things written down. Okay. All right, so that's enough of the definitions and the, starting information. We're gonna get straight into the problems. We'll do a couple practice just to show you guys, make sure we're on the same page for your assignment, and then you guys can get started, okay? All right, so let's start with number 1. So here we are looking for molarity, okay? That means in this problem, we are looking for capital M. Okay, so if you look at the question, it's asking, what is the molarity? Okay, so that means we are looking for capital M. Okay, and we know that capital M is equal to moles divided by liters, right? And so all we got to do is look at the problem, look for moles, look for liters, and then we can plug it in, and then we'll be all good. So let's take a look at the question. It tells us that it's asking us what is the molarity of a 1.25 liter solution. So we have 1.25 liters. So where should we put it on the fraction? The top or the bottom? Yeah, bottom. We're just going to put it on the bottom. 1.25 liters. Going to put it on the bottom of the fraction. Okay. It's saying that we have a 1.25 liter solution and it contains 0.8 moles of AgCl2. So we got 0.8 moles. So where should we put the moles on the fraction? Yeah, on the top. Trying to keep it as simple as I can for you. Okay, so there we go. We have our fraction, and all we got to do now is plug it into our calculator. And I know it's been a long break, but hopefully you guys remember that everything on the top we're going to multiply, but everything on the bottom we're going to divide. Now, we're going to start with the number on the top. Okay, 0.8. Okay, there's nothing else on top to multiply with, so we can ignore that. And we're just going to divide it by 1.25 on the bottom. And there you go. That's your final answer. 0.64. And then we have to label our numbers. We have to put molarity AgCl2. Okay, and that's it. That's basically what we'll be doing today. It'll get a little bit trickier than this, but basically it'll come back down to this. Alrighty, do you guys think you could try one on your own? Yeah? Okay, so I'll give you guys about 2 minutes. You can work with the person next to you. I want you guys to try number 2. It's asking what is the molarity of a 5.8 liter solution, contains 0.25 moles of KBr. Okay, just make sure you guys have a calculator because obviously we'll need one. And then this will be a good time to pull out a periodic table because some of the future problems will require. Okay, so take about 2 minutes to try that out. Okay. All right, so in this problem, it's asking us to find molarity again, right? So we're looking for capital M. Now, we know that capital M, again, is equal to moles divided by liters, right? So we're just going to look at the problem, find moles, and find liters. Okay, how many moles are in the solution here?
0.25.
Yeah, 0.25. So we're just going to put 0.25 on the top. And then how many liters are in the solution?
5.8.
Yeah, 5.8. So we're going to put 5.8 on the bottom. Okay, so that's it. That's what you should get for your fraction. Okay, now we just need to plug and chug in the calculator. So we're going to do 0.25. We're going to divide it by 5.8. And then we get a final answer of 0.043. Now, I know that we can round it differently. So as long as you give me something close to this answer, as long as it's 0.04, and then if you want to end it there, you can end it there. If you want to put 3, you can put 3. If you want to put 1, you can. But I'm going to end it right here, okay? As long as you get something close to 0.04, okay? Oh, and it's not moles. It is molarity. All right. Any questions on this one? Hopefully not too bad. Yes.
Does it matter how many like numbers after you put?
So I always recommend giving me 2 numbers that are not 0 after the decimal point. That's kind of the general rule, but I mean everyone rounds a little bit differently, and I'm not going to be super picky about that. Okay. All right, you guys think you could try a harder one on your own? Yes. Okay, let's move on then. Okay, so we got number 3. This is the one that I'll have you guys do. And I'll put your equations up here just so as a refresher, but you should have this in your notes. But take a look at number 3, and I want you guys to work with the person next to you and see if you guys can figure this one out. It's a little bit different than the one that we just did. Hopefully you can identify what's different and figure out a solution. But I'll give you guys about 2.5 minutes to take a look at the problem, try to solve it out, and then 2.5 minutes we'll go over it, okay? But we are going to be using the formula that we just learned, same thing as before, okay? Good luck, guys. Okay, so if we take a look at this problem, same thing, we're looking for molarity, right? So we're still looking for capital M. Okay, and we know that capital M is equal to moles divided by liters, right? Okay, so let's start with the moles because that's pretty easy. How many moles are in this problem? Yeah, 1.2. So I'm just going to put 1.2 on top of the fraction. Okay, and all we need now is liters, and so we can just put in liters on the bottom. Now, the problem is, do we have liters in this problem? No, right? We got milliliters, and that's the thing that was different that you had to take into account. So if we need to turn milliliters into liters in this problem. Now, if you guys remember what I showed you in your notes, how do you go from milliliters to liters? Yeah. Yeah, exactly. You're going to divide by 1,000. Okay. So all you're going to do is do 9,700 divided by 1,000. And that is going to give you 9.7 liters. Okay. So that's what you had to identify before you solved the problem. Okay. You have to turn milliliters into liters. Okay. And then from there, we just take 9.7 and we throw it on the bottom of the fraction. And then after that, we can plug it into the calculator, and that's our answer. Okay, so we're going to do 1.2 divided by 9.7. And there you go, 0.123. If you want to round that up to 0.124, you can. Doesn't really matter. I'm just going to put 123 because that sounds funnier. Okay. Molarity of NCNBR2. Okay, so this is our final answer. All right, any questions on that one? Okay, so just keep that in mind. Just a rule of thumb for this class, whenever you see milliliters and you're trying to find molarity, just turn it into liters. It'll just make your life easier. Okay.
Oh, we're gonna work on it.
Yeah. Okay, so now we're gonna move on to number 4. I'm gonna go through it step by step with you, and then after this one, there's one more problem, and then we're all done for today. Okay, so let's go over this one, and this is the last type of problem that you'll see on your assignment for today. Okay, so let's take a look at this problem. It's asking us what is the molarity, and so again, we're using the same equation. So I hope that you're noticing that everything is kind of going back to this equation right here. Okay, we're looking for molarity. Okay, now it's asking us to find the molarity of a 100 milliliter solution. Now, if you guys see milliliters, we're going to turn it into liters. So let's just do that right off the bat. Okay, we're going to turn 100 milliliters into liters, and we can do that by dividing by 1,000. Okay, so if we plug that into our calculator, we can just pull it out. 100 divided by 1,000 gives us 0.1. So we can just turn this into 0.1 liters. Okay. And then we can plug it into our fraction. Okay, so far so good. Okay, so now that we fixed the milliliters, let's go on to the next part. And it's saying that it contains 3 grams of salt, and it gives you the chemical formula. Okay, so now we have a problem because we have our number in grams, right? But we need it in moles to find molarity. And the reason why we need to know how to do this is because if you remember on a scale, it doesn't tell you how many moles there are, right? It tells you how many grams your chemical weight. So we got to turn grams into moles. Okay, so that's the next step that we need to do. We need to turn grams into moles. Okay, and then whenever you're trying to turn grams into moles, you might want to jot this down. You always want to find the molar mass. Okay, the stuff on the periodic table. So like I told you guys at the beginning of the year, everything kind of just builds on top of itself. If you didn't learn molar mass, you're not going to know how to do this. Later in the unit, we're going to do stoichiometry with this. And so everything just constantly builds on itself. Don't worry. I know you guys worked really hard to learn stoic, and I'm not going to waste your hard work. We're going to be incorporating again in a couple lessons, okay? So just make sure that you guys keep up with everything. The more you fall behind, the harder it is to dig yourself out of the hole. Unless you really want to see me next year, because then I'll see you next year, okay? All right, so we're going to turn grams into moles with molar mass. So we're going to find the molar mass of our chemical, which is NaCl. So let's do that, okay? So I'm going to put that right here. I'm going to get rid of this. Okay, so let's look for the molar mass of NaCl, okay? So what we're going to do is look at our periodic table and let's look for those elements. So let's look for Na. If you guys take a look at Na on the periodic table, what's the molar mass of Na? Yeah, 22.99, just a number on the bottom. So let's write that down. So Na has a molar mass of 22.99. Okay, and Cl is made out, and NaCl is made out of chlorine. So we're going to go to chlorine on the periodic table and look for its molar mass. What's the molar mass of chlorine? Yeah, 35.45. So we're going to plug that in right here, 35.45. Okay, and all we got to do is add them up, and that will give us the molar mass of NaCl. And that should give us 58.44. And make sure you guys write it correctly. It has to be grams divided by 1 mole. Okay. So now that we have molar mass, we can use this to turn 3 grams into moles. Okay. So we're going to set up a fraction. So we're going to write 3 grams of NaCl. We're going to set up a fraction. Same thing that we've been doing. We want to get rid of grams, right? So if I want to get rid of grams, where should I put it on the fraction? Top or bottom? If I want to get rid of grams. Yeah, bottom. If you want to get rid of something, you always put it on the bottom of the fraction, okay? And then we're looking for moles here, so we're going to put moles on the top. So this is where we're going to throw in the molar mass. 58.44 is next to grams, so we're going to put that on the bottom. And then there's 1 next to mole, so we'll put that on the top. Okay, and the reason why we do that is so that the grams can cancel out, and all we have left is moles. Okay, so for the math, remember top divided by bottom. So all we're going to do is take our starting number, which is 3, divided by 58.44. And that will give us an answer of 0. And we can round it to 0.05. 0.05 moles. And we can finally put that into the top of the fraction. 0.05. Okay. So I know this is a lot of steps, but it's all stuff that we've already learned. And at the end of the day, we're just putting it back inside of this equation, okay? Okay, so last step, we just need to solve out this fraction right here. 0.05 divided by 0.1 gives us 0.5. So our final answer here is 0.5 molarity. And that is our answer of NaCl. All right, and that's it. All right, any questions on any of those steps? Guys good? Okay, so I'm gonna actually, for the last problem, I'm gonna have you guys try number 1 on your homework since you're gonna be doing that anyway, and then we'll go over the answer. So I'll give you the answer to one of your homework problems. So let's pull up your assignment. Actually, let's not do number 1. Let's do the last problem on your homework. So I want you guys to pull up Canvas if you guys have it out. If you guys are still logging in, it's okay. I'm gonna have this up here for you guys so you guys can refer to it. But I'm gonna give you guys about 5 minutes. And since you're gonna be doing this problem anyway, okay, but I'm gonna have you guys try number 8 on your own. Okay, and then we're gonna go over it just to make sure that we're all on the same page. Okay, so take about 5 minutes. You guys can work with the person next to you, see if you guys can solve out number 8, and then we'll go over the answer just to make sure we're on the same page. And then after that, you guys can finish up the rest of the assignment. Okay, so take about 5 minutes to solve out that problem. And you could do this on your assignment paper since you'll be turning this in. You can just start with number 8. Okay. Just take about 5 minutes to do that, and then we'll go over the answer in a little bit. Okay. All right. So number 8, we're looking for molarity again, same thing as before. So let's start by writing down the equation. We're gonna need to find moles and liters in order to solve this problem. Okay. So looks like both of our numbers don't work, so we need to change them. So let's start by changing milliliters. We're gonna turn 1,500 milliliters into liters by dividing by 1,000. Okay, and that's going to give us 1.5 liters. Okay, so that's the first thing you should have done. You're going to divide 1,500 by 1,000 to get 1.5 liters. And let's just put it on the bottom of the fraction, just so we know what we still need. Okay. All right, last thing we need to find is moles. That's how we can find molarity. And so we have 1 gram of NaBr. Now we have grams. So in order to turn grams to moles, we need to find the molar mass. And we're going to find the molar mass of NaBr. Okay. So if you looked earlier at the previous problem, you should have seen that Na has a molar mass of 22.99. And then we just need to find Br. So let's go to the periodic table. Br has a molar mass of 79.9. So this is going to be, oops, wrong problem, 70.9.9. Okay, so we just need to add them up, and that's going to give us the molar mass of NaBr. So 22.99 plus 79.9, it's going to give us 102.89. Okay, so I'll pause right there. Any questions up till that point? Okay, first thing we did was turn milliliters into liters, and then we found the molar mass of NaBr. Okay, all right, now we just need to use a fraction in order to turn 1 gram into moles. So we're going to do 1 gram of NaBr. Going to set up a fraction. Okay, I want to get rid of grams, so we're going to put that on the bottom of our fraction. And then we're going to use this molar mass right here for our numbers. Okay, so 102.89 on the bottom, and then 1 mole on the top. So we just do top divided by bottom, 1 divided by 102.89. And so our answer here is just going to be 0.00, and I'll just end it at 9 moles. Okay. If you put 9.7, that's fine too. If you just put 0.009, that's all good, as long as your value is close. Okay. Okay, and then lastly, we're just going to plug it in on the top of the fraction, 0.0097 moles. And then all we got to do is divide the two numbers and we have our final answer. Okay, so if you get something close to that, you are good. Okay, 0.00. And then I'll end it at 6.4 molarity. Okay, again, our numbers might be a little bit different depending on how you rounded, how I rounded. But as long as you get something close to that, you should be good. All right. Okay, so I'll give you guys the rest of the class period to work on that assignment. If you guys have any questions, please let me know. I have the answer key if you want to check your answers. Just make sure you're doing it right. But yeah, I'll give you the rest of the class period to work.